Hello, pre-calculus students. This is Mr. McAllen. This is day 2 of Unit 8. We want to graph sine and cosine functions fully developed. These are where we have all 4 parameters, A, B, C, and D, showing, and we want to go over how we graph this function. So what we're going to first do is we're going to examine, using Desmos, we're going to examine what the answer would be. Now, this is a function we're going to be graphing, and I just want to point out that the first thing you have to be able to do is recognize what the A for amplitude, B for frequency, C for phase angle, and D for midline shift is. So I'm going to go to Desmos, and I'm going to plot that function on Desmos so you can see what the final answer will look like, and then we're going to sketch it up, and then we're going to show how we actually graph it. So I'm just going to pause the video while I bring up Desmos so I don't bore you to tears with that. And so just when I pause the video, I'll be working on that, and when I come back to the unpause, you'll see the Desmos graph. Okay, well, I'm back, and the graph was y equals 2 sine of x minus pi minus 3. And as you can see here from the graph, the midline was at y equals -3. It goes up or down an amount of 2. You can see that this is -2 and this is -1. And then it goes down to -4 to -5. You can see that since sine function, it starts right here at pi, and it proceeds to go through a full cycle by the time it gets to this value here would be 3 pi. So how do we get all of this without the use of Desmos? I mean, Desmos is an awesome tool, but how do we do this ourselves using just our knowledge of what the A, B, C, and D values are? Well, we have a set of steps to go through, and what we want to do is detail what each step entails. So the first part is when you do this, you want to find out what the A, B, C, and D values are. So let me just move this graph around because this graph is in the wrong place. So I'll just move this. I'm going to pause the video and clean this up for a second. Okay, so we're back, and the first part is to write down the A, B, C, and D values. So the A value would be the 2. The B value is the coefficient to the x, so that would be a 1. The C value is -pi. That is the phase angle. And the D value is -3. So once we get the A, B, C, and D values, this is really a review from the last day in class. Okay, finding the A, B, C, and D values. Now we put them to use to make the graph. So first, it says here in the graph, find the midline movement. So that was the D value, -3. You draw a horizontal line at -3. So we're going to go down 3. You can draw your horizontal line. This is your midline, y equals -3. The next set of steps says, find the highest and lowest values of the function. So we're going to find the amplitude tells us that the function goes up and down 2 from the midline. So we're going to go up 2, count 2 units up, and this green line represents the highest the sine function will go. And then we're going to count down 2, and you can see I'm off the grid, but that will be the lowest value. And we label those y equals -5, y equals -1. Next thing we want to do is well, I'm just going to transfer this graph real quick. I'm just going to copy and paste it. We want to find the starting point of the graph. Now, the starting point is a brand new equation, so I'm going to detail that equation. So this is something you want to take notes of. The starting point is calculated really, really easily. There are 2 ways you can remember it. The starting point, you can just remember if you know your A, B, C, and D values. The starting point is just -c/b. So if you found your C value was negative pi, you would put negative of negative pi in, and the B value is 1. So your starting value, or starting point, is just going to be pi. So you're going to actually start this function at x equals pi, or you can take what is on the inside of the function, and you can set it to 0. So this is the other way to find the starting point. You take what's on the inside of the function, x minus pi. You set it equal to 0, and that tells you that your starting point is at x equals, whoops, that's a funny looking pi. That's a funny looking pi. There we go, x equals pi. So if you remember the formula as negative c over b, or if you know how to solve for the um, linear components of what's inside the function, taking what is inside the parentheses, setting that to 0 and solving, you can find the starting point that way also. So then you go over on your midline, you find out where pi would be, and because everything is like at pi over 2 increments, I'm going to just label on my midline what my increments are, and my starting point is going to be right here at pi. So I'm going to get on the next step now, and the next step I'm going to just cut and paste what I had from before. Now remember, when you guys do this in class tomorrow, you're going to be working on the same graph over and over again, so you won't have to do this at all. So on the next step, which is step 5, we want to find the end point. Now the end point doesn't represent when the function ends, because these functions go on forever. The end point represents when one full cycle is complete. One full cycle is basically the starting point plus the period equals the end point. Now this is, the period is the length of time, or the length of x domain values you need to go through one full cycle. So remember, our starting point was at pi. The period, I'm going to show you how to calculate that, equals the end point. Now, okay, so here's how we find the period. The period has a formula. A lot of these things have formulas. The period is found by, as it says in the formula, you take 2 pi and you divide it by your b value. 2 pi divided by your b value in this case was equal to 1, so our period is just plain old 2 pi. 2 pi divided by 1 is 2 pi. So on the last problem, I had the starting point was at pi. Remember, we had pi over 2. This was 3 pi over 2, and this was 2 pi. But my ending point is going to be at 3 pi. So one full cycle will happen from pi. This is 3 pi over 2. This is 5 pi over 2. This is 3 pi. So here's where my function is going to start. Now remember, the sine function starts, one of the things we need to remember is the sine function. When you graph a sine function, you have to remember that it goes 0, 1, 0, -1, 0. These are the primary quadrantal values. So the sine function basically starts, the 0 means it starts on the midline. Oh, something's happening with my, whoa, look at this. Something's happening with my computer. So let me see if I can figure this out. That's pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi. Oh, just delete it again. Let's see if we can get through this. So now it goes from the midline up to its highest value. That represents the max. This represents the midline value again. This represents going back down to its bottom value. And this represents going to the midline again. So we draw in the sine function. And that is one cycle for the sine function, 2 sine of x minus pi minus 3. Remember, it has all the qualities. It has a midline at -3. It has a frequency of 1, which means it has one cycle in 2 pi units of width. It has a phase, it has a phase angle of -pi, which, it turns out that the starting point was equal to pi, so it started here. And it goes up and down 2 from its midline. So we did a pretty good job of drawing that function. If we go back and we look at that same graph on the original function we looked at, remember at pi it started at 0, it went up to its max, down to its middle, and that by 3 pi. So we did a pretty good job of graphing that. We have another example to try, but we're through our 10 minutes. So tomorrow in class, when we come in, we're going to work on this problem as far as recognizing the coefficients, going through this procedure. But the last thing that I want you to do is, if you can take notes on this in your notebook, I'm going to put up the last slide, which details all of those steps. So you want to have these steps written down. So we're going to go all the way to the bottom. And I'm going to just write up the steps, and then I'll unpause the video and I'll go through them for one more minute. Okay, so I wrote out the steps to just remind you about what we did. And on the first step, we found A, B, C, and D, just like we did before. Now, remember, the first step after you find A, B, C, and D is to graph the midline, horizontal line, y equals D. Then we graph the highest and lowest values of the function using the amplitude. So we go up and down by the highest and lowest amounts. That would be the amplitude. We figure out what the starting value is by using this equation. So that would be the starting point. When we label that on the midline, we find the end point by calculating the period and adding that to the starting point. So we find our end point. We mark that on the midline. Then we use our grid and we divide it up into 4 equal increments, and we then draw our function. We plot our sine function using our zero, like it's kind of like a trinary system of zeros and ones and negative ones. And if we know the function goes from 0 to 1 to 0 to negative 1 to 0, we can go through and follow one full cycle. Now, just remember that the ones are not the actual values of the highest and lowest. It should really go like 0, A for amplitude, 0, negative A for going down, and 0. But it basically tells us the pattern of the function. So hopefully this video helps you understand the basic idea of graphing the sine function. Tomorrow in class, we'll be doing a bunch of problems to practice doing this. Hopefully this video has helped, and I look forward to hearing your comments.